Now, what we have here in figure 1.3 is aspect. Okay. Now, first of all, they've given us the following. The direction, that's the north-facing slope, and that's the south-facing slope. Okay. North and south-facing slopes. Now, first of all, before I want to point out, the arrows is the insulation. Okay. What is insulation? It's incoming solar radiation. Okay. Now, very importantly, as you can see, they've mentioned the south-facing slope and the north-facing slope over here. Immediately pick up that the south-facing slope, as you can see, received direct insulation. Okay, and as you can see, this is a cast of a shadow. The slope over here do not receive direct insulation. Okay, I will get to the letters in a second. Now, first of all, define the term aspect. Okay, and it's quite simple. It's the direction, and this is quite an important definition. The direction a slope is facing, in which okay, the direction in which a slope is facing, okay, or you can mention is the angle at which the sun strikes the surface. Okay, but very importantly, I just want to pay attention to this now before I want to go, and you need to be able to understand this clearly, and I just want to wipe all of this quickly clean to explain this to you. Now, so this is north and this is south. So let's assume if these slopes were in South Africa, and that's the northern direction. So it means if we walk into that direction, we walk into the equator. So by showing you this, let's just go and identify our slopes. This slope will be the north-facing slope, am I correct? Because it's facing towards the equator. This slope over here is the south-facing slope because it's facing away from the equator. If you look at this slope, it's facing towards the equator, am I correct? And this is the south-facing slope. Remember, you are walking, right? If you're walking north, where are you going to end up? You're going to end up at the equator. Now, what do we know about the equator? Receives more insulation, okay? Much more. But as you can see, look at the insulation that the north-facing slopes receives more insulation than the south-facing slopes. We can almost say that the south-facing slope is casted in a shadow zone. Okay. Now, the north-facing slopes experience more insulation. More insulation means more sunlight. So it means it's going to be perfect for crop farming. But let's just quickly have a look at the next question. We define the term aspect. 1.3.2, what evidence suggests that this value is situated in the southern hemisphere? Simply because the north-facing slopes, this is the north-facing slope, receives direct insulation. Now I'm going to write it down there for question 1.3.2. Because the north-facing slope receives direct insolation. Okay, now I'm just going to write it there. Southern hemisphere, north facing slopes, and the northern hemisphere, it might be, they can always ask you a diagram or a figure that's situated in the northern hemisphere. Then you need to know that it's in the south facing. The south facing slopes experience more insolation in the northern hemisphere. Okay. Now, I've just mentioned this a couple of minutes ago. Explain why area A is referred to as the shallow zone. Okay, there's area A. I've even showed you the shallow zone because it's cast in the shallow, because they don't receive direct insolation. You can see the insolation traveling past the south-facing slope. Okay, so at 1.3.3, we can mention the south-facing slope does not receive direct sunlight. Okay, as you can see, have a look at that. Okay, so it will be casted in a shallow zone. Now, what they've done here over here, in question 1.3.4, explain how wind B will develop during the day. Now, this is key. They've mentioned it during the day. Okay, so because we're dealing with local climate, we're dealing with aspects over here, but we're also dealing with different types of breezes that's being experienced. Okay. Now, first of all, they've mentioned during the day. Okay, but there's two different types of breezes that we experience during daytime and during nighttime. And I'm going to explain both to you because it's quite important. Now, the question states, explain how wind B will develop during the day. Now, as you can see, there's the wind being shown in the arrow. Okay. As you can see, it's an upslope wind. Okay. Now, these upslope breezes that we experience is known as anibatic. Okay. Why? Because what happens, the air comes into contact with the slopes, the air becomes light and dense, and it starts to rise. It rises parallel with the slopes. It's known as Anibatic breezes. Okay, I'm going to write that in. Okay, air comes into contact with the slopes. Okay, and we can also mention the air rises parallel with the slopes. Okay, now, vice versa happens during nighttime, and usually at nighttime the air sinks, it gets into contact with the slopes, it sinks to the bottom of the valley, collects on the bottom of the valley, and during nighttime we refer to it as katabatic breezes. Okay, same principle will happen over here. The air comes into contact with the slopes, it cools down, it's cooler temperatures, the air sinks to the bottom of the slope. Okay, now vitally important during winter, in these valley situations, we experience an inversion. Okay, might as well just explain this to you as well. And I see that's going to be our next question as well. So especially during nighttime, when the temperature drops well below 0 degrees Celsius, the air, because it's much heavier, it sinks down to the bottom of the valley. So all the cold air collects on the bottom of the valley. Okay. But because cold air is much more dense and it's heavier, so what does it do? Moves down the slope, collects on the bottom of the valley. Now what does it do with the air that was inside the valley? It displaces the air upwards, right? Because that cold air sinks down, collects down. And what do we know? Cold air is much heavier and denser than warm air. So what does it do? Displaces the warm air, and what's being created? Inversion layer. Okay. Inversion layer, but we refer to it as a thermal belt. Okay. Now, what is the inversion layer? Let me just define it for you. Inversion is when there is an increase of temperature with an increase of altitude. Now, this is exactly what happened over here, great holes. We went from cold, because the cold air collected down at the bottom, to warm. It's not normal, is it? What's supposed to happen with temperature when we move up with altitude? It's supposed to decrease. Okay, I can give you a simple example. We go and climb Mount Everest. What happens with the temperature? As we increase with altitude, what's going to happen? The temperature is going to decrease. But now we experience the inversion, so that means the temperature is increasing with altitude. That's exactly what's happening in this valley, because we're going from cold temperature to warm, creating that thermal belt. Down in the bottom, where all this cold air collects, we refer to it as a frost pocket. Okay, as you can see. And then the thermal belt's been created because we have to go from cold to warm because the warm air has been displaced. Now let's just look at the question. So I just explained how the wind developed during the Ds because it warms up, and it rises parallel with the slopes, known as Anibatic breezes. Now question 1.3.5. In a paragraph of approximately 8 lines, give advice to a farmer on how to plan the usage of the land at place C and place D effectively, taking into account the influence of aspect and the winds that we discussed. Okay, now, the question asks, how is it going to affect? Let me just clear this diagram over here. Okay, first of all, is asking how is it going to affect the area of C and D. Now, first of all, if you look at C, it's down with the frost pocket, especially during winter. So a farmer should be very careful what he's going to plant over there. You need to plant frost-resistant crops. Because surely during winter, with the katabatic breezing, with the accumulation of cold air on the bottom, it's going to probably freeze. The temperature is going to drop well below 0 degrees Celsius. So we might experience frost. But if you look at D, you might definitely, because it's on the north-facing slope, it's going to be excellent for crop farming. But because it receives more insulation, because of the direct insulation, he needs to make a plan for irrigation. Okay, so it's going to be much more suitable on that side. Okay, so I've mentioned frost-resistant crops needs to be planted over there, right? Now, imagine, I just want to use the same diagram and base what I've drawn on the bottom. So let me just fill this in. So over here, what are we going to have here? We're going to have our thermal belt. Okay? So his farmstead, he's probably going to build his houses halfway up the slope. Okay, why not at the bottom? Because it's going to be too cold, right? Because of the katabatic breezes being experienced. Okay. Now, importantly, you're probably going to need irrigation in the north-facing slopes because it's drier, right? Might be able to plant different crops on the south-facing slopes, for instance, forestry. Okay. And lastly, what we can mention, right, once again, I've mentioned already, is the frost-resistant crops. You need to be careful for that. Okay.